you have a current password, then you can log on to the network. That is the first premises, first proposition. Then second is given, you have a current password. That is also another premises. Therefore, it is given, you can log on to the network. So in this argument, that means there is the set of propositions that is given. So in this argument, tell me which propositions are premises and which proposition is conclusion. There are three propositions. One proposition is, if you have a current password, then you can log on to the network. That is first proposition. Second proposition is, if you have a current password, and the last one is, you can log on to the network. From these three propositions, which are premises and which is conclusion?
So first two are premises and last one is the conclusion.
Yeah, the first two propositions are the premises here, and the last one after therefore the proposition is the conclusion. That means here the first two statements or propositions are the premises. And the final statement or the last statement is the conclusion. So now you can find what are the premises and what are the conclusion, what is the conclusion in a given argument. Okay. Now we'll convert the given argument to a argument form. So to make it argument form, we have to use some proportional variables. After using the proportional variables, we have to convert the English proposition or English statements to logical expressions. Okay. To write the above argument. See what is argument and argument form, that is important. The above argument will in argument form. We consider P be the proposition and Q be the proposition. See, using the English statement, if you have a current password, then you can log on to the network. That is a conditional statement. So there will be two propositions, P and Q. So P will take you have a current password. Q, that is you can log on to the network. P is, that is you have a current password. Then Q, that we are taking, you can log on to the network. Now we'll create an argument form. So the above argument, the given argument has the form. That form is called argument. What is that form? We'll convert all the given proposition into logical expression. See, what are the given? First one is, if you have a current password, then you can log on to the network. Then what will be the logical expression to this? using the proportional variables that we have taken P and Q. What will be this? If you have a current password, then you can log on the network. That is if P then Q. That means P conditional Q. Got it? Then what is the next proposition? Next proposition is only given you have a current password. That means only P. Then write P. So then what is the conclusion? Conclusion is what? Conclusion is you can log on to the network. That is the conclusion. So that is Q. So these P conditional Q and P, these are called premises. And Q is the conclusion. So this whole form is called argument form. What is I mean? See, premises implies conclusion. So write all the premises, that is P conditional Q, one premises and another premises is P, and the conclusion is Q. Write in this form. This form is called argument form. This symbol, that is for therefore. That stands for therefore or hence. So you can check that this argument is valid when this argument is valid. Why? Because if you just take if P conditional Q is true and P is true, then Q must be true. That can be checked by the truth table. How? See, when P and Q are the proportional variables that we have taken. One can check that P conditional Q and P. That means if all the premises are true, that means P conditional Q is true and P is true, then conclusion is Q is true. That means the whole statement is a tautology. That means this argument is valid when this statement, what is that? Conjunction of all the premises conditional to conclusion must be a tautology. If this is a tautology, then we can say that this argument is valid. Okay. That means whenever all the premises are true, the conclusion also true. That means you can see that means that is the same thing. When all the premises are true, conclusion must be true. That means the argument form is valid when all its premises are true, the conclusion must be true. That is the same thing. You can check conjunction of P. One is P conditional Q, that must be true, and P is true. We are taking these two are true. Then the conclusion is true. Conclusion is Q. Okay. So we have checked that this argument is valid as this is a tautology. So using this, we can write here. an argument in propositional logic. Is valid if and only if. What is the if and only if? The argument form is valid. That means if the given, we are showing that the given argument valid, so just convert the given argument to a argument form. So just show that that argument form is valid. If the argument form is valid, then the given argument must be valid. When the argument form is valid, we can check the tautology. That means see, then tell me the argument form with premises P1, P2, like Pn, finite number of premises P1 to Pn, and conclusion Q is said to be valid. What is the condition? That means the argument form is given. In that argument form, premises are P1, P2, Pn, and Q with the conclusion. This argument form will be valid. What will be the condition? If all the premises are true, then conclusion is true. That means what? See, in this example, there are two premises. One is P conditional Q, another is P, and the conclusion is Q. So this argument form is said to be valid when the conjunction of P conditional Q and P. This implies Q. That implies Q means conditional to Q. This will be a tautology. Then we can say that this is valid argument. Or if all the premises are true, then the conclusion must be true. It is the same thing. If all the premises implies the conclusion, that means what? That means then what will be tautology? Anyone? Conjunction of all the premises. That means P1 conjunction P2 conjunction up to Pn. So conjunction of all the premises conditional to conclusion Q is a tautology. That means if this statement, that means conjunction of all the premises conditional to conclusion is a tautology, then we can say that argument form is valid. If the argument form is valid, then we can say that the given argument is valid. Okay. Now come to rules of inferences. To deduce or create new statements from the statements already have. That means from the given statements, we are creating a new statement or new propositions. We will use some rules of inferences. Which are the templates for constructing valid arguments. Then you see rules of inferences, that are nothing, that are some formulas or standard rules to create new statements or new propositions using the given one. So always remember, when using rules of inference, so always we are constructing or creating a valid argument. So that argument must be valid. Okay. See the definition of rules of inference. A relatively simple argument form that is valid, or which is valid, is called rules of inference. That means, see, rules of inference is nothing. So that we have studied the argument form. See that D type argument form. P conditional Q. That means using all the premises, conclusion. This form is argument form. So this type argument form or some rules or some standard argument forms that are which argument form is valid. So these type of argument forms are called rules of inference. So rules of inference, there is no new definition. So that are the argument form or some standard argument forms that are called rules of inference. That argument must be valid. That means valid argument form. That are called rules of inferences. Okay, we have some standard rules of inferences. Rules of inference means that is the standard argument form or valid argument form. Then what will be the tautology for that rules of inference, and what is the name of the rule? First one is, one proposition is P, another proposition is given as P conditional Q. Then the conclusion will be Q. That means these are the premises. These are the premises. Here Q is the conclusion. So that is a standard argument form. So this is valid or not? This argument form is valid or not? One proposition is P, another proposition is P conditional Q, and then the conclusion is Q. This is valid or not, you can check by tautology. What will be tautology here? Conjunction of all the premises implies or conditional to Q, conditional to conclusion. That means P conjunction, P conditional Q. That is the conjunction of all the premises, conditional to conclusion Q. So that will be tautology. If that will be tautology, then that argument form is valid. So argument form which is valid, that is called rules of inference. So these argument form or rules of inference, that name is modus ponens. Modus ponens. That you have to remember which argument forms and what are the names. Negation Q, that is a one premises, another premises is given P conditional Q. Then is one premises is negation Q, another premises is P conditional Q. If the conclusion is negation P. Here, then what will the tautology here? What will be the tautology here? Negation Q, conjunction P conditional Q. That means conjunction of all the premises implies conclusion. Conclusion is negation P. So this name is, this rules of inference or argument form name is modus tollens. P conditional Q, Q conditional R implies, or therefore P conditional R. This name is hypothetical syllogism. Then what will be the tautology here? What will the tautology here? Conjunction of all the premises. If all the premises are true, implies that conclusion is true. Premises are P conditional Q and Q conditional R. Conclusion is P conditional R. That means conjunction of all the premises. First premises P conditional Q, conjunction to Q conditional R. This implies or conditional to conclusion. Conclusion is P conditional R. So this will be tautology. You can check that. So all the form we have written, these are standard forms. So you can check that that must be a tautology by using truth table. You can use the truth table also by for proof. Okay. Next one is P disjunction Q, negation P. This concludes P disjunction Q, negation P. These are two premises. Implies or the conclusion is Q. Then what will the tautology here? What will the tautology? Yeah.
So P disjunction Q,
Yes.
conjunction negation P,
Yes.
whole
Then, yeah.
conditional Q.
So this will be a tautology. You can check by the truth table. As it is a tautology, so all the premises imply the conclusion. This is a valid argument form. So as it is a valid argument form, this is called rules of inference. So this name is disjunctive syllogism. So all these argument forms, for what type of argument forms, what are the names? You have to remember that names are important. So that will be used in your problem. Only one premises P, and if the conclusion is P disjunction Q, so tautology will be premises P conditional to conclusion. Conclusion is P disjunction Q. So this type valid argument form is called addition rule or addition rule of inference. Next one is premises is P conjunction Q. Then the conclusion is only P. Then P conjunction Q conditional to P. It will be a tautology always. So these rules of inference or simple argument form or valid argument form is called simplification. Then P is one premises, Q is another premises. The conclusion is P and Q. Then what will tautology here? Very simple. P and Q. So conjunction of all the premises P and Q conditional to P and Q. So this rule is called simply conjunction rule. P disjunction Q, negation P disjunction R. This concludes Q disjunction R. That means if P disjunction Q is true and negation P disjunction R that is true, then we must say that Q disjunction R must be true. That means P disjunction Q and negation P disjunction R. These both are premises. Premises all are true. Implies premises implies the conclusion. Conclusion is Q disjunction R. So all are tautology. So as it is a tautology, so this will be a valid argument form. This name of the rule is resolution. See, rules of inference that are called also, you can say simply valid argument form. Okay. P conditional Q. From P conditional Q, we can imply negation Q conditional to negation P. Then P conditional Q, you can check that P conditional Q conditional to conclusion. Conclusion is negation Q, negation P. So that is a tautology. So this rule is called contrapositive rule. So these are some standard valid argument forms which are called rules of inference. Some particular valid argument form, there are some specific names. So you have to remember these names. This rule of inference or these names will be used in solving the problem. Example or problem question is, so that the given premises that is given, it is not sunny. This afternoon and it is colder than yesterday. That is the proposition given. And again it is another proposition given. We will go swimming only if it is sunny. That is the another premises, another proposition given. All those argument is given. And it is given if we do not go swimming, then we will take a canoe trip. It is also given if we take a canoe trip, then we will be reached at home by sunset. These all are premises are given. These premises lead to the conclusion. Conclusion is given that we will be home by sunset. Example or a problem. So that the premises, all the premises are given, premises lead to the conclusion. See here, the given all are premises. Here the last one is the conclusion. Maybe if maybe it is given if premises or conclusion is not given, only given the argument form, all the proposition will be given argument for that these argument forms is valid. All the premises lead to conclusion. That's the same thing. The argument is valid. So to show that this argument is valid, we have to first convert all the propositions to logical expression using some propositional variables. Then we will use the argument forms or standard argument forms or rules of inferences. Okay. Let P be the proposition. See, it is not sunny this afternoon and it is colder than yesterday. That is a we'll take from these two propositions. One is it is sunny this afternoon. Q be the proposition. It is colder than yesterday. Then tell me what will be the next proposition variable. Let's take R. What will be R?
We do not go swimming.
No, then it is given we will go swimming.
Oh, sir, I said for the third one. If we do not go swimming, then we
No,
will take.
then come to sequence wise, one by one. Okay. First, it is not sunny this afternoon. We have taken one propositional variable, and it is colder than yesterday. That is one proposition. Then it is given we will go to swimming only if it is sunny. So we will go to swimming. That is, we will go swimming. Then only if it is sunny. So it is sunny already used. So that is P. Then come to S. What will be S? What will the variable S?
Sir, we will take a canoe trip.
Yeah. So we do not go to swimming. So that is not required because we have already taken RH, we will go swimming. From that, we will take the negation, that will be we do not go swimming. So S will be we will take a canoe trip. Then any another variable is required or not? Then if we take a canoe trip,
We will
then
be home by sunset.
yeah, then we will be home by sunset. So let T be the variable. We will be home. We will be reach at home by sunset. So then any other proportional variable required or not?
No, sir.
No, because the last conclusion is we will be home at by sunset. That proportional variable we have already taken. So using all these proportional variable we have taken, we will convert the given premises as well as conclusion to logical expression. Then tell me what will be the first proposition or first premises. It is not sunny this afternoon and it is colder than yesterday.
So negation P conjunction Q.
Yeah, negation P conjunction Q. That means now we will convert all the given premises in English sentence to logical expression. Now, then the given premises become, we'll write one by one sequentially. First one is negation P conjunction Q. Okay. What will be the next? Next is we will go swimming only if it is sunny. Tell me what will be the logical expression?
Sir, P conditional R.
P conditional are how?
Sorry, sir. R conditional P.
Yeah, R conditional P. That is will go swimming. That is your R. Only if it is on its P. So R conditional P, not P conditional R. That will be wrong. So R conditional P. Then what will the next? If we do not go swimming, then we will take a canoe trip. We have taken R as we will go swimming. So we do not go swimming, that will be negation R. So then we will take a canoe trip, that we have taken S. You can take also other variables. That depends on you. So that will be negation R conditional to S. And what will be the last one? If we take a canoe trip, then we will be reach at home by sunset. That will be what?
Sir, S conditional T.
Yeah, S conditional T. These four are all are premises. Then what is the conclusion? What is the conclusion? We will be home by sunset. That is the only one proposition. That is T. So conclusion is T, and the premises are this. All are premises here. That means there are four premises, one conclusion. That means if all the premises are true, we'll show that conclusion is true. So now we can use all the conjunction of premises conditional to T. That will be a tautology. So we will not go through by tautology. We will use rules of inference. How to use rules of inference, we'll see. Now we'll construct a argument form using all the premises. That means see. Step 1. First take the premises. So negation P, conjunction Q. That is the premises given. First premises. So this concludes what? Any idea? Negation P, conjunction Q. Okay. See the rules of inferences. So that you have to remember. See one number. Rule number 6. P conjunction Q implies P. So that is rules of simplification. So simplification rules of inference say that if P conjunction Q, then P. That means this is a tautology. So as this is a tautology, P conjunction Q implies P. So we can, then what will be this? Negation P conjunction Q implies what? P conjunction Q implies P. So negation P conjunction Q, that implies negation P. By using which rule? You have to use by the right hand side by using simplification rule. That is important. By using simplification rule. Then negation P is the conclusion here. Again with negation P, we'll use another premises, that is R conditional P. That is your step 2. Step 2 means what is one conclusion is negation P. Again with negation P, we'll take the another premises R conditional P. Now we are taking these two. R conditional P, that is the another premises we are using. Then tell me negation P with R conditional P implies to what? Okay, see the rules. Second rule. See the second rule. Yeah. What is second rule? Negation Q. And one premises is negation Q, another premises is P conditional Q. This implies negation P. It is always checked. That means it is a tautology. Negation Q, conjunction P conditional Q, conditional to negation P. This is a tautology. As this is a tautology, the standard argument form is valid. That is called modus tollens rule. What is that? Negation Q, P conditional Q implies negation P. Similarly, just see this. Negation P here, R conditional P implies to what?
Negation R.
This implies negation are, you have to write by using what? That is important. By using modus tollens rule. Okay. Then negation R is, now we are getting negation R. So step 3, negation R will take another premises. So negation R conditional to S, that is another premises. So using these two now, one premise, now the premises are, one premises is negation R, another premises is negation R conditional to S. This implies what? Negation R conditional to S implies what? See the first rule. First rule is modus ponens. That is, one is P, another is P conditional Q. That implies Q. See the first rule. First rule. One proposition is P, another is P conditional Q. These two premises concludes Q. That is modus ponens rule. So using modus ponens rules, one proposition is negation R, another is negation R implies S. So these two premises concludes to what conclusion? P and P conditional to Q, like this. What will be the conclusion?
Sir, S.
Yeah, it will be S. By using modus ponens. Okay. Then S is, now S is the conclusion. We'll take this. Yeah, 10. Okay. S, now we'll take another premises, S conditional T, that is given another premises. So using this, what will be the conclusion? One is S, another is S conditional to T.
P.
Yeah, that conclusion will be T. T is the final conclusion by using modus ponens rule. See, step 2 means negation P, R conditional P implies negation R. Step 3 means negation R conditional S implies S. Step 4 means premises are S and S conditional T. Conclusion is T. That means we have used all the premises. Using the rules of inference, we conclude that T is the final conclusion. That means we have proved that this argument form is valid because we have used all the valid argument form by using rules of inference. Rules of inference means valid argument form. So we conclude that just last statement. The above argument form or this argument form shows that the given premises lead to the desired conclusion. So this type question must be asked in your exam for long question. Using rules of inference so that the given premises leads to the conclusion. Okay, we'll stop here. Yeah, any doubts? Just tell me. Anyone is asking something? Okay, just wait.